And let's do a cosmology segment. So, smAsho.org is an emerging science foundation. And we've created our own websites here. smAsho.org will redirect you to smAsho.com. You can find our social media and contact information there, as well as links to our 3 different merch shops, smAsho Merch, smAsho Store, and Smash Store, as well as our forum. And if you go to the forum, you will find this. The latest forum thread, I believe, is a forum thread about the, quote, grand solar minimum, end quote. So, by the way, the thread is open to whoever wants to post and has no bias nor agenda. The thread is neither attempting to convince of nor detract from the, quote, grand solar minimum, end quote, hypothesis. The first thing I've done is put up this graph here, which is 1,000 years of solar activity. So what you're looking at here is, this is the carbon-14 counts, this top line, and this is taken from wood samples in European wooden structures. They were built at a known time, so we're going back 1,000 years here. We're using a proxy of cosmic ray flux here, in that cosmic ray flux creates carbon-14, and the wood stores that carbon-14. And what you're looking at are the solar cycles here. So the frequency of these spikes and troughs have 11-year periodicity, going back all the way to 1,000 years, which tells us something. The 11-year, or you could say 22-year full solar polar reversal cycle certainly was most likely still going on 1,000 years ago. And we only have sunspot numbers back into the 1700s, when they first started to be counted, when people had telescopes. So, in any case, check out this chart and let us know in the comments if you see a cyclicity here. The only cyclicity I see is the 11-year sunspot cycle. I would note a larger range since sunspot counts started to happen. Nothing else on that. And remember, folks, heliophysics is cosmology. It's part of the reason why we cover it. Now let's take a look at a random object here on the Neil Gorell Swift-Bat X-ray Observatory. Today's random number between 1 and 1031 is 107. Yesterday we looked at supernova at 1987A, and entry 107 is NGC 1275, a Seyfert 2 galaxy, which is a type of active galactic nucleus, otherwise known as 3C84. Here are the X-ray transient outputs of galaxy NGC 1275. Let's take a quick look at it on SIMBAD. Is it a spiral galaxy? It looks like it's an irregular galaxy. Pretty cool. And we'll look at it in a few wavelengths here on Aladdin Light. It looks like it's a semi-spiral galaxy, as we see some evidence of spiral arms here. It's kind of like in between an elliptical and a spiral galaxy, so it's an interesting one. Again, otherwise known as 3C84. Here it is in the infrared spectrum. And let's see what it looks like on Chandra, the Chandra X-ray telescope. And it has quite a large X-ray range here. I guess I would call this mainly an elliptical galaxy. Again, you can see some evidence of spiral arms there, as well as these blue spots here. These are dust lanes where there is less X-ray emission because it's being absorbed, refracted, and or heated up. The dust is absorbing, heating up, refracting, and orienting to electromagnetic radiation there. And it's obscuring some of those X-ray emissions. And that's today's cosmology segment, ending with galaxy NGC 1275, Seyfert 2 active galactic nucleus.